Another problematic question was question number 13. A gas is contained in a cylinder by a movable piston. The gas is heated at constant pressure. You should know this. According to the laws, if pressure is constant, then it means that volume is proportional to temperature. How is the force of each collision of a gas particle with the piston affected? And how does the frequency of collisions between the gas particles and the piston change? So remember, the gas is heated, meaning that by heating the gas, the temperature increases. Now you must understand that the temperature increasing, kinetic energy is proportional to temperature. So temperature increasing, kinetic energy of the molecules increase. Now if the molecules are moving faster, it is obvious that if the molecules are moving faster, they will collide with the walls of the piston with more force. Something moving faster and the same thing moving slow. When it is moving faster, it collides with a bigger force with the walls of the container, of the piston. So the force increases. However, if the force increases, then the next question asks us, how does the frequency of the collision between the gas particles and the piston change? Now you must understand that the frequency of collisions are not only dependent on, but the pressure here remained constant. So this is something that you must know, that the pressure remained constant. So pressure remaining constant, the pressure is force over area. If pressure remains constant, then there must be a reason why pressure remained constant. It is obvious that when temperature increases, the volume increases, meaning that the surface area increases. So the surface area increases, but pressure is remaining constant, meaning that the actual total force is decreasing. So force is a function of two things. Force is a function of two things when you're talking about gas particles. Force is caused by two things. Force is a function of the speed at which a molecule is colliding with the walls of the container. So the higher the speed, the more the force. But the force is also a function of the number of collisions. So take for example, if this speed increase, so for a lower speed, let's say that the force, there are 10 molecules, the force for each molecule was 5, then the total force was 5 by 10. The total force was 5 by 10, which would mean that it was a 50. Each molecule contributing a force of 5. Now, there are 10 molecules colliding with the walls of the container, and there were 10 collisions. That's what I want. There were 10 collisions. Now, if the force due to one molecule increases, but the overall force has decreased, then it must mean that the number of collisions has decreased, because there are only two things contributing to the total force: the force due to a single collision and the total number of collisions. More collisions per unit time, and combined with an increase in force for each collision would increase the force. But if the force of a single collision has increased, but the overall force has decreased, it means that the number of collisions per unit time has decreased. So the number of collisions per unit time has decreased because pressure has remained constant, force has decreased to maintain pressure constant. So in other words, the frequency decreases, frequency being the number of collisions per unit time. Number 15 was another problem. A chef heats some water on a hot plate. The temperature of the water rises by 10 degrees Celsius in time t. She then puts the same volume of oil in an identical pan on the same hot plate. So the same volume of oil as compared to the volume of water. So the volume is the same in an identical pan on the same hot plate. So meaning that the power provided by the hot plate is the same. The specific heat capacity of water is 2.5 times that of oil, and water is 1.1 times denser than oil. So water is 1.1 times denser than oil. So the question asks you, what is the time for the temperature of the oil to rise by 10 degrees Celsius? What is the time for the temperature of the oil to rise by 10 degrees Celsius? That is the question there. What is the time for the temperature of the oil to rise by 10 degrees Celsius? So how do you approach such a question? You approach it holistically. You say, okay, for the water, we know that energy supplied is equal to mc delta theta. But the energy supplied, suppose we have got the same watt plate, meaning that its power is the same. That's what it means, the same watt plate. If its power is the same, then power is energy over time, meaning that energy is power times time. So power times time is equal to mc delta theta again. Okay, that is fine. Now, we are not told of the masses, but what we are told of is of the densities. So the density of the water is 2.5 times that of oil. Water is 1.5, sorry, the specific heat capacity of water is 2.5 times that of oil. The water is 1.1 times denser than the oil. So let us start with oil and consider oil. For oil, let's say that the power is the same that it is receiving, but we don't know the time. But remember, density is mass. Mass is density times volume. So for oil, let's say that its density is rho. Its specific capacity is C. Rho times V, they've got the same volume, remember? Its specific capacity is C. And the temperature change for both of them is 10. Now, if we say this for oil, then for water, we are told that its temperature rises in time T. So we use T now. Its density, we are told that it's 1.1 times the density of, of oil. Then its specific heat capacity is 2.5 times the specific heat capacity of oil, then times 10. So knowing this now, what else do we do now? Knowing this, we can go further and then multiply 1.1 times 2.5, which gives us 2.75. 2.75 rho VC10. So rho VC10 that we see here is the same as the rho VC10 that we see here. So I can come here and say PT is equal to 2.75. Where there's rho VC, I'll then put PT1. PT1 like that. P and P cancels. Remember, we're looking for T1, the time for the oil to rise its temperature by 10 degrees Celsius. So I divide both sides by 2.75. So 1 divided by 2.75, that gives me 0.3636, which is 0.36 ultimately. So T1 is 0.36, like that.